Okay, so let's try to do example 8. So let's read the question. So the moon has a mass of 7.35 times 10 to the power of 22 kilogram, and the radius of the moon is 1740 kilometer. Okay, so a probe of mass ni macam satellite lah, of 100 kilogram is dropped from a height of 1 kilometer onto the moon surface. So calculate its change in gravitational potential energy. So what happened over here is we have a moon over here. Okay, moon bukan macam tu kan, dia bulat-bulat macam tu. Okay, so I'm going to draw two moon. Okay, so we have a probe of mass. It's dropped from a height of 1 kilometer. So let's say lah, this is 1 kilometer. So let's say this is your probe of mass, super satellite, and then the jatuh drop onto the moon surface. So kat sini pula. Okay, so calculate its change in gravitational potential energy. Change means delta, and then change in U lah. So we have U initial and then we have U final. So kita akan calculate separately. So let's try to calculate it separately. So U initial, the formula is negative GMM over R. So this one will be negative 7.67. And then this one, M ni adalah mass of the moon, which is this one, 7.35 10 to the power 22. And then this M will be your mass of the probe lah, which is 100 kilogram. And then your R would be always from the center, iaitu from here to here. So this one is the radius of the moon. So maksudnya 1 kilometer plus dengan the radius of the moon, which is 1740 lah. So remember SI ni untuk distance adalah meter. So you have to make it time to the power of 3 for kilo And then this one, I think you will get 2.8159 darab 10 kuasa 8 joule. Okay, kenapa ada sebab kenapa Miss letak 4 puluhan nanti kamu tengok. So let's try to do the next one to calculate the U final. The same formula. So I'm just gonna put the same value lah. But this one, your R would be from here, from the center of the moon, which is the radius of the moon is 1740 times 10 to the power of 3. Okay. Oh, sorry, we don't have square. Okay, so be careful So this one you will get negative 2.8175 darab 10 kuasa 8 joule. Okay, so notice that this one kan, if Miss put 2 decimal places, it will be 2.82 kan. So also will be 2.82. So I cannot find the change lah. So if you encounter in the exam kan, bila kamu buat kat sini 2.82 and then kamu pun dapat 2.82, so it's a sign that you must put your decimal places to be banyak sikit lah, so that the change ada value bukan kosong. Okay, so we know that delta U is actually final tolak dengan initial lah. So U final is what? Negative 2.81. Okay, just put the numbers back and then minus lagi this value over here, 2.8159 darab 10 kuasa 8. Okay, and then your answer would be negative 1.60 times 10 to the power of 2 joule, I think. Yeah, so this one will be 0 lah, 2 joule. Okay, so that is the answer for A. So let's try to do B pula. So for B, dia minta if all the gravitational potential energy loss is converted to kinetic energy, calculate the speed at which the probe hits the surface. Okay, so dia minta speed V lah, so dia nak nilai saja. Okay, so what happened here is this the gravitational potential energy loss ni adalah change in potential energy tu lah. Okay, sepatutnya energy is conserved, right? But in this case ada energy loss kat situ, which is sepatutnya nilai dia sama lah. Okay, tapi tak sama, that's why dia change. So this is the gravitational potential energy loss lah. So I'm going to write down the value over here. is converted to kinetic energy. So maksudnya ditukarkan sama nilai dia dengan kinetic energy. So dia mintalah speed tu kan, bila prop hits the surface. So dia nak minta speed bila dia ke bawah kat sini. Okay. And then I know the formula for kinetic energy is half mv square. So obviously we want the speed of the prop, so mesti kita akan guna mass of the prop. Okay, so notice that I put sign here, over here is positive. Kenapa? Sebab Miss nak jawapan final Miss V2 positif. Okay, kenapa Miss nak jawapan nilai V2 positif? Sebab dia nak speed saja. So speed is always nilai, and nilai tu sentiasa positif lah. So kalau dia ada negatif ataupun positif, so dia dah bagi tu direction kat situ. Okay, so just put the negative over there, and then this one will be half mv square. So mass of the prop is 100 kilogram. And then kamu selesaikan, tekan calculator, then your answer will be 56.89 ms negative 1. Okay, thank you.